Hi Falcons. Today what we're going to be talking about is states of matter and phase notations. Phase notations are just how we represent the states of matter in a chemical equation. The states of matter that we're going to be looking at here would be, first one will be solid, represented by an S. Solids have a definite volume and shape, and the particles are kind of packed closely together. They're the highest density out of the three physical states. The particles in a solid, they don't move in relation to one another, but they do vibrate in relation to the amount of kinetic energy they have. If that kinetic energy is great enough, meaning that it's actually a measure of their temperature, if it's great enough, they will eventually melt and become a liquid. Liquids are symbolized by an L. They have a definite volume, but an indefinite shape. What that means is they can change shape to fit their container or flow, but they can't change their volume or be compressed. So it's kind of showing you here the particles are able to move in relation to one another, but they can't be squeezed into a smaller size. The third physical state is gases, represented by G. Gases do not have a definite volume or shape, and the particles are at great distance from one another. Actually, this diagram doesn't really give it justice. They would be much farther apart and moving much faster. As an example, oxygen gas at room temperature is moving at about 1,000 miles an hour. So they're moving much faster than this diagram would show, and they're actually much farther apart. Gases do also fill the available space through a process called diffusion, so they'll spread out in the container they're located in. This is kind of just to show you those three physical states in relation to one another. There is a fourth physical state known as plasma, but we won't be discussing it or really using it in class. Plasma is really found in stars or in lightning. It's when matter gets heated to a point where the electrons actually get ripped away from individual atoms, but it's something that, while very interesting, is not something that we're going to be using in our regular everyday class. The last phase notation is aqueous. Aqueous denotes something that's been dissolved in water. It's symbolized by AQ, and it is a physical change. It's one of the things that students most often miss with this one, is because they see the salt go into the water and it disappears, and they think that it's a physical or a chemical change, when in fact it's a physical change. Those particles that are being dissolved are simply being surrounded by the water molecules and pulled apart, but they're not bonding with anything. It could also be reversed, typical of a physical change, through a process called evaporation, where the water can be heated off and leaving that solid behind. What I'd like to do with you guys now is try a couple problems where you have a sentence and you convert it into a chemical equation. This first sentence reads, solid zinc reacts with an aqueous solution of hydrochloric acid to produce hydrogen gas and aqueous zinc chloride. What you'd want to do first is separate the things that are reactants from products. In this case, that would be the solid zinc and aqueous hydrochloric acid as reactants, and the hydrogen gas and aqueous zinc chloride as products. We would separate them by an arrow, putting the reactants on the left and the products on the right. We would need to include this phase notation to denote the zinc as being solid, the aqueous hydrochloric acid as being AQ or dissolved in water, hydrogen gas, G, and then aqueous zinc chloride, AQ. What I'd like you to do now is pause the video and read this sentence and try and make the equation yourself in your notes. So hopefully after pausing the video, what you've seen is that water and lithium metal were our reactants, and hydrogen gas and aqueous lithium hydroxide were our products. The water obviously is a liquid, the lithium is a solid, the hydrogen gas is a gas, and the lithium hydroxide would be denoted with AQ. Thanks for your time, Falcons. I hope this was helpful.